Before we get too deep into the course, there's a few prerequisites that you need to have in both skills as well as setup on your machine. We will be using Java for this course. Now you can use Kotlin with Spring, but we're going to be focusing on Java here. I will be using Java 17 for this course since it's an LTS version. With Spring Boot 3.x, you have to at least use Java 17, but since we're not going to really be focusing on the Java language per se, you can use anything newer than Java 17. Now, since we are doing Java development, you're going to need a JDK installed. It doesn't matter whether it's from Oracle or OpenJDK, just make sure that it is a JDK and not simply a JRE. You also will need to have Maven installed on your machine. Now, this is sort of an optional because you can use the built-in scripts that are included with Spring Boot if you choose to, but I will be using an installed version of Maven. Now, let's discuss the knowledge you will need for Spring itself. You will need some basic Spring knowledge. This course is not an introduction to Spring itself, but instead a way to write Spring code to be more testable. As such, there is an expectation that you know Spring. If you are new to Spring as a whole, I suggest you stop here and take my course, Learning Spring with Spring Boot, or Spring Boot Essential Training to get that baseline knowledge. If you are a Spring veteran, Spring Boot isn't a very far jump, but you will need to understand how Spring Boot operates with auto configuration because we're going to be leveraging that in our testing environment. You will also need to fully understand the IOC container and how Spring uses it for dependency injection. Now for the tool that you will use the most in any development or learning exercise, and that's your IDE. I will be using IntelliJ Ultimate Edition, but what I am using is not important. What is for you to be most concerned about is that you understand and are familiar with your IDE. In other words, I need you to use what is comfortable to you, not what I am using. All of the functions that I will be using in my IDE are available in every other modern Java IDE. I do encourage you, beyond even the scope of this course, is to learn the keyboard shortcuts as well as the context menu options for your IDE because these will speed up your development. Now, there are a few optional things that I will be using that you can choose to use or not. First and foremost is Postgres. You will be given a working web service for which to work from. Now, you're not going to need to actually run that web service unless you want to, but if you want to run the web service, it needs a local Postgres engine. Now, I'm going to be using Docker to run my Postgres image. Again, if you don't want to run the web service as a whole, all of this is a moot point. But with Docker, I have the ability to simplify installation of the database across many different platforms. That being said, the start script that I provide you for Postgres to use Docker is specific to Unix or Mac OS X. And as such, if you are using Windows, you will need to modify it, especially around the volume command. But that being said, this is all optional, and this is just how I do development. Finally, I'm going to be using a tool called HTTP-Py. There's also an equivalent tool called curl, both of which allow you to execute web requests from the command line. Again, I'm going to be using this as examples, but these are not things that you're going to need to do to run the code for the testing itself. These are things that will help you write web services as a whole. And if you choose to take the base package that I'm providing you as part of this course and extend it to extend your learning, tools like this will help you be much more effective in building out the web services. With all that being said, it's time to jump into code. The concept of test-driven development is pretty well documented as a whole, but there are aspects of it that can be discussed in a language-specific or framework-specific way. So let's take a moment and talk about the concept of test-driven development. The key premise here is that requirements drive tests, not code specifically. Tests are written based on the requirements first and foremost. Code is then written to ensure the tests pass, at which point you have well-tested code that matches the requirements. Now, refactoring of that code can take place as needed, so long as it doesn't break the tests themselves. If requirement changes impact existing tests, the test should be modified before the code itself is touched. Now, while TDD is a development process, it does have some impacts on the actual code being written. First and foremost, code must be written to be tested. While TDD focuses on the requirements, you still need to test the cyclomatic complexity of the code itself. So yes, all code must be written with testing in mind, but in my opinion, this is more true with TDD. You can get into issues with just testing the requirements, especially on edge and boundary conditions. So you need to have a way to trigger those boundary conditions to allow you to build a more robust test suite. One of the biggest impacts to code itself is that isolated code needs to be tested both in isolation, what we often call white box testing, as well as together, often called integration testing. With Spring, the framework provides everything needed to make this happen, and that's what we're going to focus on in this course. So now let's talk a little bit about testing itself within Spring. The first topic I want to discuss is unit testing. Now, for the most part, we're just going to use standard Java to do our unit testing within the Spring framework. If you build your objects to inject via the constructor, it actually makes testing significantly easier, especially if you want to use stubs instead of mocks. Now, we're going to use mocks just because that's what I traditionally use, but stubs are just as easy, and by leveraging constructor injection instead of field injection or auto wiring, you actually can get a much easier path forward to injecting in your constructs when you're writing tests. Now, Spring does provide some mock objects for things like environment if you need to leverage those within your test itself. We're not going to get into that because it's pretty well documented, but if you have specific conditions based on environment values within your class under test, you can leverage these mock objects to handle those environment variables. There's also some AOP test utils and reflection test utils that you can use if your class under test requires AOP or requires reflection in order for you to actually be able to pseudo mock those and still be able to do unit testing. And there's MVC test utils, which we are going to take a look at in a little bit. They allow us to test MVC containers from within a test apparatus. Now this brings us to integration testing. Now, of course, the argument will always exist. Should you do integration testing in a deployed environment? Should you do it locally? How do you make it most effective? And ultimately, is it better or worse than unit testing? All of that being said, Spring has some opinions on integration testing in general. First of all, they have built the framework to allow you to do integration testing outside of actual deployments. Many of the things that they are giving you with these integration testing patterns actually are easier than testing it on a deployed system. They handle all of the wiring of Spring dependencies as well as test fixtures for you within the framework. They give you access to data access itself without leveraging a production database or even a test database. You can run them embedded into your context itself, and you get full access to transactions as needed. There's also a lot of specialization within the integration testing framework. Now, we're not going to talk about all of them, but we are going to look at a few of them. And they give you full access to context management as well as caching, so you can modify the context within your integration test as you see fit. Now, some of the specializations that they give you, I want to talk through very briefly here. They give you JDBC, data access, and embedded databases, and we're going to touch on these in our integration tests themselves. They also give you a test context framework if you need to leverage testing outside of the actual application. You actually get this for free, and you may not have ever seen it, and we're going to play with this as well some. They give you an MVC test client. Now, the MVC test client has several key values that you can use, including testing client calls, as well as your actual MVC container. And you get that MVC container through mock MVC. We're going to play with that quite a bit because this is one of the most powerful ways that we can do integration testing. And if we build our integration test properly, we can do isolated integration testing as well as the entire stack, depending on our needs. Add in unit testing. We now have a full test suite that we can leverage to get better test coverage of our applications, whether we're using TDD or not. And ultimately, TDD should be driving your integration tests, and then you decorate your testing with specialized integration tests, with isolated integration tests, and with your unit testing itself. So let's jump into code so we can actually take a look at some basic unit testing within the Spring framework. Now I'd like you to open up your exercise files and you will see that I have built for you an application under Wisdom Pet API as well as a data directory under bin. Let me give you a real quick rundown of the setup that I am running. I'm running a local Postgres database that I've started with the Postgres start.sh file in the bin directory. I then executed within that database the postgres-data.sql file, which loaded a database schema as well as created some tables and added a whole bunch of data. I can connect to my live database here in my IDE and open up, say, the customers table, and you will see that I actually have data that came back out under the TDD schema. Now, with that said, I'm now running my application in a web service container, running it through my IDE, and I simply type HTTP localhost 8080/customers. I get data back out, and that data is coming from the database and my working web service. Now, in TDD, we wouldn't necessarily start with the code, but it's much easier to show you how to test the code if we have the code running. And we're going to start with unit testing because that's the most easy to come up with as we get started. So in source test Java, so the first thing that we are going to do is in the base package in source test Java, we will create a new package called service. And we are going to take a look at testing our customer service. So we will write a new Java class called customer service test. All right, now within our test class here, the first thing we're going to do is do an extends with, and we're going to use the Makito extension.class. We're going to leverage Makito to do our actual mocking of our elements. Again, because this class was written with a constructor injection, you could use stubs just as easily, but I'm going to go ahead and do mocks. So we will inject mocks into our class under test. We're going to inject mocks from a customer service that we will simply call customer service. Now, what we need to mock, if you take a look at this class real quick, is we need to mock the repository. And the repository is an interface, but it works just the same. So we will mock a customer repository, and we will simply call it customer repository. So now let's write our first test. And we are going to do a get all customers test. And we will do a Makito.doReturn. And we want to return get mock customers. And we're going to create this method here in a minute. We're going to pass it the number of elements that we want it to create. And we're going to do that when we call customer repository .find all. All right, so now we will do a list, and the list will be of customer. And we will simply call this customers. And that equals this dot customer service dot get all customers. And we will write a very simple assert equals to customers dot size. Go ahead and import in that assert equals. Now we need to write this method that is going to be used to get our mock data. So we will do a private iterable customer entity get mock customers, and we will pass it an integer of the size, and this is the size of the element that we want to get. So within there, we will simply create a list of customer entity customers equals new array list, and we will send in the size. And then we are going to do a simple for loop. I equals 0, I is less than size, I plus plus. And we will add a customers.add new customer entity. And within our new customer entity, we will call uuid.randomUUID. We will send in a first name, and we'll go ahead and add to that the number. We will send in the last name, and again, we will add into that the number. We will do email plus the number plus @test.com. And we will simply put in a phone number here. So 555-515-1234. And let's fix that. And the final element that we need to put in here is an address. So we'll just do 1234 Main Street. And then we can simply return customers because list is of type iterable. So now we can actually test our service. Let's make sure we've got all of the errors taken care of. It looks like I've got one. And that is I put my return in the wrong spot. Now we should be good. So we can execute this test, and I'm just going to run it right here in my IDE. And get customers has passed. That's all there is to unit testing. It's the same as within Java. We actually haven't done anything with Spring, and that's sort of the power of doing unit testing because it's the same everywhere. And just like that, it's time for our first challenge exercise in this course, and that's going to be on unit testing. I've got some instructions for you. The first thing I want you to do is to test the remaining public methods for the customer service. So we're going to test get, create, update, delete, and find by email. I also want you to look at how you might test the error states. If you look at that class, you'll notice I throw some exceptions. Take a look at how to test those with Mockito. Now, this is going to be a little bit of a stretch and something you're going to have to learn on your own. And that's it. Get it tested. Look and see if you can catch all the cyclomatic complexity. Have fun with this one, and I'll be back with my solution to this. Now it's time for my solution to this challenge on unit testing. So after our Get All Customers test, I went and started to implement one for Get Customer. You'll see here that I had to create an optional instance of a customer entity, and that is what I returned when I did the call on Find by ID. I then did the actual call and validated that what I got back was what I expected. Now, if you look at the code, there is a situation where Get Customer with an invalid ID that doesn't exist returns a not found exception. So I've done that with an assert throws annotation out of Mockito, and I'm asserting here on line 61 that the not found exception is returned when I call Get Customer. It actually is thrown, not returned. Then I did a test for Find by email address, much the same as I did for Find by ID. I then did a test for Add Customer, and I want to call your attention to line 80. Because the interface returns what it takes, and we had to do some modification to ensure that we had an ID set in the add method, I've gone and done an any on this. So it will take any customer entity and return an entity. Now this is where mocking starts to run into some problems, and this is why it is not sufficient to just do unit testing, because we're not really fully testing anything other than if I send this method, I return something back out, but I don't really have any complete looking at this from top to bottom. We're going to get to that here in a little bit. I also did a test on add customer for existing, and this is another exception case where I throw a conflict exception. I then did a test on update customer, and once again, because update calls the save function, I'm passing an any into it. And then I did a delete. And I want you to take a look here on line 112. I did a do nothing because it's a void method. It doesn't return anything. I also created another helper function here on 117 to return a mock entity that I'm using in all of my tests. That's how I executed this. Now, a couple things I want to point out, and again, this exists on every IDE. I can run this with coverage. And what this allows me to do is once all my tests have passed, I can pull up an actual coverage of my class. Now, you're going to need to look at how this is done in your IDE, but what you will see is each line in this case is green. Had I not tested a line completely, it would show up as red in my IDE. Now, Surefire, which is a Maven plugin, will give you the same type of data. You can also get this through other tools. So you're not limited to this in IntelliJ, and you're going to have to do some looking at how it works. But almost every Java IDE and definitely Maven plugins will give you code coverage analysis, which gives you a very clear indication if you're actually testing your code. And let me just show you what happens if I bring up a class that we have yet to test. So I have no coverage data on this because we haven't tested it. It has no way of knowing if we have done any coverage. Unlike what I get here in customer service, where right next to the line numbers here, I've got the coverage. I have nothing in the controller. So we're going to fix that as we get going, but this is a useful tool that you should look into how to do this in your IDE. So now we've taken a look at some basic unit testing and you've had a chance to do some on your own. Now we're going to take a look at some basic integration testing. So let's jump back into our IDE, and there's a few things that we need to do in setup before we can get going. So the first thing that I want you to do is in source test, right next to Java, I want you to make a new folder called resources. Now in my IDE, to make this very clear, I'm going to mark this directory as a test resource root. Maven will do that automatically, but I like to have it documented so I make sure I'm putting things in the right spot. Now in here, I want you to go back up to the bin directory that came with the exercise files. And I want you to copy the data.sql and the schema.sql files down. Go ahead and drop those in. And if you take a look at these files, they're much trimmed down versions of the original data file that I gave you. And that's because this is test data. I don't need nearly as much. However, in order to use what we're going to do, I need to go into my Palm file. And I need you to go down to around where the database is. And we're going to add another dependency. And the dependency that we are going to add is h2 from com.h2.database. You don't need a version, but you do need to put in a scope here of test. Now, what this is going to do, we're going to set up an integration test that is going to leverage this database as a test database using the schema as well as the data files that we have provided in source test resources, while at the same time not impacting the main run. And to prove it's not impacting the main run, I'm going to run, after I do a Maven import here, I'm going to rerun the application itself, get it back up and running. We can take a look at the output here, and you will see we're using a SQL dialect of Postgres. Well, we're not using H2, so that indicates that Postgres is still running. Furthermore, if I run back into my terminal, I can run that command again, and I'll still get data out from the database. I've got 100 results. We can go scroll through them all. We got 100 results back out, which is what we had in our original database instead of the 5 that we were presented with in the test file. So with that said, let's go ahead and create our first integration test. So right next to our customer service test, let's create a new class. We will call this customer service integration test. Now, in order to run this as an integration test, we are going to annotate this with @springboot_test. And at this point, we can provide any extra configuration that we need to. The only one that we need to do, however, is to do an auto-configure a test database. And we're going to do a replace of replace.any. Now, this is going to allow it to auto-configure and replace the database in our application with an embedded one. So we will simply auto-wire in an instance of our customer service. Simply call that service. We will write a test. And the test we will do is on get all customers. So we will do a list of customer object called customers equals this dot service dot get all customers. And we will do a very simple assert equals 5 customers dot size. Now I will warn you, doing things like this that test numbers, assume that your database never changes. That's not going to happen. So we either have to clean up everything or modify this. For the purposes of this demo, this is fine. But in the real world, you're going to want to modify this in a way that it's very clean and you're always ensured you're going to get your results back. Now let's go ahead and run this integration test. You'll see that Spring is actually starting up. And if we go through our logs here, we can see that the SQL dialect being used is H2, which means we are now running our test database container. And indeed, our test passed, which gave us an indication that our 5 count is correct on the size, which matches our data.sql file. That's all there is to simply running an integration test using an embedded database and letting Spring run the container for you. So now it's time for our next challenge exercise, and this one is on integration testing. Some basic instructions. I want you to test the remaining public methods for customer service using integration testing. So it's going to be very similar to our last challenge, but instead of doing the mocking, we're going to use the embedded database. And once again, I'm going to ask you to test the error states because that is good programming practice to test the full cyclomatic complexity of your class under test. So enjoy this one, have fun with it, play with it a little bit, see what you can come up with, and I'll be back with my solution. Now it's time for my solution to the integration testing challenge. Much the same way that we did before, I simply started going through all of the methods. So I did a call on get customer, passing it a valid ID from the database, and then validated that the name was what I got back out on line 36. I then created a new GUID that didn't exist in the database and ensured that when I did a call to get customer, that it threw a not found exception. I did an add customer. Now you will notice on line 50, I did some cleanup. And if you remember, I talked a little bit about the concern of doing a test as we did on line 29, where you're testing the size. Depending on the alphabetical order of your functions, that can change the behavior. So by doing a cleanup on this, I've ensured that I will not impact other tests because I add it. And then when I'm done testing the method, I then delete it. Now, technically in doing so, I'm testing delete itself as well, which is why you will find that I don't do a test on delete formally. I then do a test on adding a customer that exists by email address. So I create a unique customer, but share the email address. This throws an exception. In doing so, I'm also testing the get by email function because that's what we're doing. Then I do a test of the update, and once again, I clean up when I am done. So while I haven't actually officially tested all of the methods by calling them from their own distinct method set, if you look at coverage, I am completely testing this class, and that's what's most important here. So with that being said, that's all there is to doing an integration test at the service level. Now we're going to do an integration test at the web level, which takes a whole nother perspective that we're going to get into next. So now that we've done some isolated integration testing, I want to take it to the next level, and that is to test the entire stack through integration testing. So let's do that. Let's jump back into our IDE, and underneath the base package in source test Java, let's create a new package called web.controllers. In there, we will create a new class called customer controller integration test. Now, once again, we will annotate this with Spring Boot test. We will also do an auto configure mock MVC, and we're going to talk about what that is here in a moment. But for right now, we've got one more annotation, and that is to do our database once again. And very much the same way, we'll do a replace and replace.any. Now, the whole reason we did the auto configure mock MVC is so we can auto wire into our class an instance of mock MVC. Now, what mock MVC does is it creates a pseudo dispatcher servlet, which allows us to test the methods as though it were running in its own servlet container. And in fact, it's a mock servlet container. But with that, we can do a test on get all customers. We need to put in here throws exception now. Even though that's proper for all tests, you don't always have to do it. In this case, we need to because we can throw an exception out of this. So this.mockmvc.perform. So now we're going to do a get, and this is a get operation on /customers. And we will do an and expect, and we are going to expect a status of is okay. And we'll get to all of these imports here in a moment. And we will expect our content to contain a string. Contain string. Now I want you to open up the data file here and just grab one of these UIDs. And we need to keep track of which ones we're going to use, but for right now, we're fine. So we'll use the first one, and let's do another and expect statement. Content. Actually, let me do a couple carriage returns here real quick just to make this a little easier to read. .string, and it contains string, and we're going to do the last one. All right, so now it's time to do some imports. So we will do the hamcrest contain string matcher. We will do content on servlet request. Now to do this get, I'm actually going to type this out because get has a lot in here. So we will do an import static on org.springframework.test.web.servlet.request.mock.mvc request builders.get. Again, get is very common, so it's a lot easier just to type that. You'll remember that after a few times. But that's all that there is to doing this test. So let's go ahead and run this. And you'll see that we've passed. So we've tested that our content includes a couple of GUIDs. And of course, we could have tested the entire JSON blob. This is sufficient. We pulled a couple variables out and tested that they're there. We've called it, we've tested the status. And this is all there is to doing mock MVC testing, but it's a very powerful construct that you can leverage when doing TDD or any kind of testing within Spring. Now it's time for our final challenge exercise for this course, and that is building out the web integration testing. So our instructions, and these should look very familiar at this point. I want you to test all of the web methods that are available in our controller. I want you to also be sure to test all of the exception cases within those. Now, this is a great opportunity for you to consider how to test this effectively. Remember, we talked about checking the accounts coming out of the database, but then when you add or update things, things can change. So start to think about a strategy here that you want to employ in order to consider how you would test this as your API grows. And I also want you to take this time to consider how you would do this with TDD, because this is really the layer that TDD comes the most into play. These are the acceptance criteria for your requirements, because this is what your API must return. Everything else is simply adding to the testing of our package to ensure that we don't break things. But this is really where the requirements meet the road. So take a look at this and think about it from that perspective as you're writing your tests, and I'll be back with my solution. Now it's my turn for the solution for web integration testing. So much like we've seen several times before, I've written methods that handle the exception cases as well as the standard cases. We'll start here on line 39. I have a test to get customer. I get it by its full URL. I'm expecting a status of OK, and I validate that the customer that comes out has the ID that I passed in. I also do a test here on 45 if it's not found. So I pass in a GUID that does not exist in my database, and I get a status of is not found. There's nothing else to validate. The status that came out is not found. Now, if you build your system such that not found returns things like messages and error codes, which is a very valid concern, this is a great place to actually test that what you get back out is what you expect, even when you get a not found. So do consider how you communicate the errors out of your APIs. Now on line 50, I do an add customer, and you'll see that I'm using an object mapper, so I can create a customer object, turn that into a string, and then I'm passing in content that is that string with a content type of application JSON. I'm expecting that I'm getting back out a created status, and then I test that the email address matches. I then do a very similar test where I'm doing a test of the exist functionality. So I create an object that looks exactly like the object from the database, except for the ID, use the object mapper once again, and I ensure that I'm getting back a conflict. Now on update customer, I do very similar things. Here I'm actually testing a couple elements coming back out, making sure that I'm getting okay. I then do a bad request to test my mismatch condition where the URI path does not match the object coming in. This is a great test on an update because you want to make sure that everything is the same. And I make sure that I get a bad request back out. And then I do a delete. Now, this is a good opportunity for you to consider the case had my original test of get all customers looked at the count, it would be broken at this point. I've added a customer and now I've deleted a customer. It's luck of the draw. It's technically alphabetical, but you still have too much at play to leave it to happenstance. So you really want to control your tests as you're looking at them coming back out. So with that said, that is all that there is. If I run this test, you will see that everything passes and I am good to go. So at this point, we've got unit tests, we've got intermediate integration tests, and we've got full integration tests of a web service API. Everything that you've learned, however, can be extended, and we'll talk about that next.